As sensing and computing elements become inexpensive, low power, and miniaturized, mobile devices become ubiquitous. A significant detriment to the proliferation of these devices is the limitations in battery technology. Airflow energy harvesting presents one promising solution to this problem in various contexts. In this demo, we present a simulation and prototyping toolkit called Exergy, which is designed for airflow energy harvesting in vehicles. The Exergy toolkit consists of a desktop simulator, and a power conversion and management hardware system, and a software library for embedded system integration. To explain the features of Exergy, I'm going to walk you through the steps on how to create a self-sustainable wireless camera systems. In this design task, we need to consider three major requirements. First, the system should be able to generate 800 mW, which is the power demand of the camera system. Second, the system should be self-powered at a speed of 20 mph. And lastly, we wanted to install this system to the roof of the sedan. The first step is to select the vehicle type in an Exergy simulator. This simulator can support a sedan, SUV, heavy truck, motorcycle, and bicycles. The second step is to design the simulations. You can choose either a real-world driving scenarios or a static driving speed. You can adjust the size of the wind turbine. We'll use a default value 4 inch here. And you can enter the power demand of the target system, which is 800 mW. And then the final parameters of the simulation is the location of the system, which is the roof of sedan. And you can see the movable point, which is a red color dots. You can also select the top, right, or left area of the surface. Once you complete the design of your simulations, you can move to the third step, the execution of the simulations. You can start the simulation by clicking the Run Simulation buttons. It will return 4 results: driving speed, and the wind speed at the location of the system. And when it comes to the power, it visualizes the power demand and then the estimation of the harvested power. As a final step, Exergy simulator analyzes the results in a descriptive format. Again, you can compare the power demand and then the expected power. It confirms whether your target system would be self-powered or not. In case the system could not harvest enough power, the simulator suggests the ways of improving the performance of wind energy harvesters. After completing the simulations, you can start to manufacture the system with the Exergy hardware approach. Exergy includes a bracket with a strong magnet and 2 power management circuits, lithium polymer battery, LED, and custom built propeller, DC motor, wires, and pre-programmed ESP32 camera modules. The first step is to interconnect the propeller with the DC motor to convert the rotational energy to electricity. You can then connect a buck booster DC-DC converter to the DC motor. After that, the power manager needs to be connected. It can control the power path, charge the lithium polymer battery, gauge the battery level, and regulate the voltage. Before moving into the next step, you can confirm the system operations with LED. You can then connect the battery and the pre-programmed camera modules. This is the final outcome. For evaluations, we check the wind speed through the anemometer. As you can see on these screens, the system was able to transmit the video signals while charging the battery from the power harvested in the wind turbine.